Good morning, all conference participants, and thank you for the moderator for giving me a chance to present our work. And now I would like to present our research project called LoRa SNR Evaluation as Portable Sensor. And my name is SeKoDa as the first author in this research. On behalf of my friends, Husnuzan Hidayat Pratama, Dharma Rusdi, Rikil Ruli, Tony Kurniawan, and Abdul Haris. This is my short introduction about myself. My name is SeKoDa and my research area is smart agriculture, LoRa wireless sensor network, and the last one is unmanned aerial vehicle. And this is my email address. So you might be interested in my research or having a discussion. So please don't be hesitant to text me. So our current research topic in wireless sensor network, we are using LoRa as one of the tremendous infrastructure for the IoT, especially. And as we know that the LoRa has an advantage in large area coverage and also the energy efficient. So currently in the last 3 years, we've been working out, and we are going to dig more about LoRa by operating it dynamically in the wide area operations. So one thing that interesting in deploying sensors in the network is how to keep or to maintain the data quality. And our focus research in how to guarantee the data quality in the dynamic operations. The dynamic operation is mean that the sensor is not deployed statically, but it's deployed in the mobile mode, so we can move another point to another point in an area, so we can achieve the efficient of numbers of sensor we should create. And this is the area of experiment that we are trying to explore. This is our location in our campus. This is the location of our campus here. So the circle here is determined for the coverage area of a LoRa sensor. Beside the spread vector that as a number 7, 8, 9, 10, 11, 12. This is the spread vector, and also this is the SNR along with the signal coverage. Okay, so the SNR means that we know about the level of the noise whenever the transmission is occur from gateway to the end node. Okay, basically the LoRa system, as we illustrated here, that the LoRa gateway is set in the center of the area experiments. Then the end nodes will be placed in beneath the sensors and also the spread vector here. So the maximum spread vector, it's when the outer range of the network is signed by the 12 numbers here. And our project is trying to move that the end nodes, it will be moved to 8, will be moved to 9, 10, 11, and 12. Then we can get the SNR value here, and also we are add some position using a GPS in here, so we know exactly where the sensor position really is. And to get more about the result, this is the methodology that we set first is set the area of work, area of experiments, the location, and we trying to relocate end nodes every time to see the value, and then we trying to get the real SNR value from the site. And the last one is we have to analyze what is the highest level of the SNR and where is the lowest level of the SNR. And the LoRa device that we engage here is a LoRa chipset is SX178S, and the frequency operation is 915 megahertz, and the LoRa gateway is 8 channel. Only a single gateway we use that in this experiment, and the LoRa class operation is A, and the GPS module is U block 6M. And this is the formulation that we use to get the deviation of the SNR from the real SNR that has the standard formula in here. Okay, now for the result and discussion from these experiments, that we have the variety value of signal to noise ratio in several points that indicates the travel of the end nodes that we doing here. So this is the example of the value of SNR. This is the coordinates, and this is the SNR value, and this is the one of the example is 27.5, and this is 25, and this is minus 3.8, and this is the 23.3. And then we trying to collect from this all the data from this point, and we got the average of the real SNR value is 25.028571 and 42. And then for the maximum SNR, we have a 35.414190639, and for the minimum is 17.50829832. So the deviation for the of the SNR value here, as we can see, the standard of deviation for all those for all SNR is 3.7, and for the maximum is 4.3, and the minimum is 4.7. Then we're trying to we are visualize the population, the distribution of of the SNR value here. As you can see in this, we have a two visualization here. The pattern of the SNR maximum value is around is a this is the distribution, the normal distribution, and the maximum is more in this level, and for the minimum value is more in this level. Okay, and this is the another visualization using a box plot here, and then this is the real SNR value that we get, and this is the maximum value that we can see, yeah, the range, and this is the minimum value of the SNR distribution here, and this is the outlier. There's some value that quite far from this toleration value from the SNR. Okay, for the conclusion is that the operating LoRa in dynamic mode is possible to do, and the changes in SNR value can be very significant even at the same location. It's been that depends on the situation, like a weather or maybe another obstacles that we are facing at the time that the data is get. And then the third one is for the next development of the dynamic sensor or the portable sensor, we are going to engage a deep learning approach to make a predictions so we can minimize the loss or losses in the data, yeah, or the quality of the system itself. Okay, thank you so much for your attention. Good day.